All right, on 5.7, what this kind of savings account is going to do for you is now it's going to compound it daily. Okay, so you're going to calculate the interest for daily compounding, meaning it happens once a day, rather than once every 3 months or once a year or once or twice a month or something like that. This time it's happening daily. So on page 232 it says, more often banks compound interest, the more potential you have to earn more interest. Many banks offer savings accounts with daily compounding. When they compound interest daily, it is computed each day and then added to the account balance. The account will earn interest from the day of the deposit to the day of the withdrawal. You can use a table to calculate this. So just so that you guys know, we're going to use another table for this one. Okay. Now, this is an account that, again, means every day we'll get a number, or they'll get interest off of it, and they'll put it into your account and just keep going every day. The two formulas that we're going to use says amount is going to equal your original principal multiplied by amount of $1. Now, anytime you see amount of $1, like we had last Friday, that means a table. That means a chart. Okay? So for this particular thing, we're going to look at the original principal, and you're going to multiply it by the amount of $1. And again, that comes straight out of a chart. Then, to figure out compound interest, this formula I think I've wrote now, this will be the third or fourth time that I wrote this one in this chapter already, but it's your amount minus your original principal. Okay, so what that means is that you're going to get the final total, and it might say how much money did you earn in interest, so then you have to subtract it from what you started with to see how much you actually made. So again, the first formula, we're going to find a number in a chart, and you're going to multiply it. And the second one, if we are asking you, or if it's asking you how much money did you earn in interest, you subtract it from what you originally started with. Okay? So that last formula, by the way, I think that's at least the third time I've put that up there, maybe even fourth in this chapter already. So it's not anything new that way. Okay, on number 1, it says Ramona Odin deposited $6,000 at 5.5% interest compounded daily for 25 days. And what we need to figure out is we need to figure out what was the amount that's in there now and how much money did you earn. So there's two answers. So in order to do that, there is a chart. There is one in the back of the book, but there's also a little one on page 232. So first of all, for Ramona, her original principal is $6,000. That's the original principal. Now in order to figure out the amount of $1, we look up the chart for 5.5%, which again, on 232, there's a little snippet of it. And you look for 25 days. What number is associated with 25 days? On page 232, there is a chart. It says days. Which one is the one that has 25? What's the number that's associated with 25? 1.00377. Thank you, Jordan. Okay, again, that's where we get that number, is straight out of the chart. So what is 6,000 times 1.00377? Okay, anybody else get that? Yeah, okay, good. So that was how much is in the account right now. Then in order to figure out, which would have been part A, in order to figure out part B, which says how much did you earn, you take the 6,000 that you initially started with and minus the number that's in there now. And what's $6,022.62 minus 6,000? $22.62. That's part B. Okay, there was part A. And the bottom is part B. All right. On page or number 2, it says Chuck Lang deposited $6,000 at 5.5% interest compounded daily for 31 days. So it's the same amount, but the difference is it's different number of days. So for 31 days, what's the multiplying number for 31 days? 0.0468. And when you multiply those out, how much do you get? Which? I hope you guys, huh? Oh wait. I hope you guys understood that with this particular problem, we had 6,000 for Ramona, and we also had 6,000 for Chuck. Chuck left his in for 6 more days than Ramona, so his should be bigger, right? Okay, you should have more money if you leave it in there longer. That's part A. Part B, now we need to subtract how much he started with, which he started with 6,000 to begin with. So what's 6,028.08 minus 6,000? 28.08. Careful when you're saying 0.8, because 0.8 is 80 cents, not 8 cents. So be very careful when you're saying that, because sometimes you guys are writing it differently, and 80 cents is way different than 8 cents. Okay? So just be careful with that. What do you think? Now, the thing that's going to be a little bit different for you for number 3, it's not necessarily the same or any difference. The big thing is you're going to have to figure out how many days it is. Okay, so what they're going to do is they're going to give you the same numbers like that, where they give you the 6,000 or they give you what percentage, but now you have to figure out how many days it is, because it's going to tell you 2 dates. On number 3, it says on March 3rd, Raul Avila deposited $10,000 in a savings account that pays 5.5% interest compounded daily until June 21st. So you have to go from March 3rd to June 21st. So let me show you something in your back of your book that's going to be helpful to you. Go to page A10. On page A10, that page right there is how we can do the entire assignment, because at the top of that page, there's the amount for $1 chart. Okay? That whole chart's there, and it goes anywhere from day 1 to 40, and then it goes by tens after that. Okay? Now, here's how we're going to do number 3 when it says from March 3rd to June 21st. On March 3rd, we're going to use the bottom chart. What number, when you look at March 3rd, March is the 4th column over, okay? And the 3rd one down, what number is associated with March 3rd? 62. March 3rd is the 62nd day of the year. That's what that meant. Now I want you to find June 21st. Right? Because that's the number that wants you to go to. Isn't it? Yeah. 172. So now, here's what happened. I asked you to look up March 3rd, and you said it was the 62nd day of the year. June 21st is the 172nd day of the year. That's what that number is telling you. So how many days is it between them? What operation do you think we're going to do to find that? Yeah, subtract them. Take the big number minus the little number. What's 172 minus 62? Is 110. Good. So between March 3rd and June 21st, there's 110 days. Bless you, Jordan. Here's the alternative. March 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th. You're going to have to count it. Do you want to count it? You can. Okay, the alternative is that you count it on your hands or figure it out that way. Me personally, I would use the chart. So you find the day that it coincides with as far as how many days into the year it is, and then subtract the two. Now, on that same page, what number for the multiplying number at the top is associated with 110? 1.01670. Thank you, Brad. So what is 10,000 times 1.01670? Too much. Yep. 10,167. So what was happening there, what Brandon was telling me, he was a little bit too far. He went a little bit too far past. This has 4 zeros, right? So 1, 2, 3, 4. We'll go right there. Okay? So what he did was he added one more zero into there. So is 100 and, how many thousands did you say? 101,000, a little bit different than 10,000? Yeah, just a little bit. Okay, so be very careful with that. Now, that was part A, which part A says how much money was in the account. Part B would be how much did he make? So if you started with $10,000, if you subtracted out $10,000, you'd have $167 is how much they earned. Not bad for 110 days worth of nothing, right? Because you didn't do anything to get that money. You just put $10,000 in an account and let it go. So not too bad. Number 4. That's at 5.5%, right. You don't get 5.5%. It's less than, yeah, it's way less than 1%. My savings account that I get for interest is 0.25%. On March 26th, Samuel Griffin deposited $20,000 in a savings account that pays 5.5% interest compounded daily until July 24th. So using the time-lapse table, we went from March to July. I don't even remember the dates now, even though I just said them. March 26th to July 24th. So March, then the 26th. What number is associated with March 26th? 85. What number is associated with July 24th? 205. I take the big one minus the little one. What's 205 minus 85? 120. Okay. Now on the top chart, what's the multiplying number for 120 days? 0.01823. So what is 1.01823 times 20,000? What big decimal? Okay, flip back to page A10. Look at the top chart, the top part, and look for 120 days. That's where I'm getting that from, Colin. 364.6?
Yeah.
Like 60, not 06?
Nope, just 6.
Okay, thanks. So, after 120 days, I had $20,364.60 in my account. How much did I make? If I subtract out 20 grand, that's how much we started with. How much money did I make? $364.6. Right. Okay, on page 234 now to get you to let you know what's going on for 5, 6, 7, and 8. It says the principal. Remember, principal is the amount of money you started with. And then it either tells you the number of days or it tells you 2 dates. If it tells you 2 dates, you have to do what we did up here on the screen. If it tells you the number of days, you just have to look up that in the chart. Page A10 is the chart number that you're going to want to look for. To find part A, you take your principal times by the multiplying number. Part B, you subtract out the original principal, and that gives you how much money you earned. Okay? And the same thing on the next ones. The only difference is now they put words behind it as compared to a chart. So they actually give you a person. So on page 233 to 234, we're doing 1 through 12. Now, just to kind of give you an idea